All right, y'all, this is going to be note card 18, the quotient rule. So in the previous note card, we learned the product rule. The product rule, again, was in note card number 17. And what the product rule says is that if f of x equals, I don't know, g of x times h of x, then the derivative equals, so when the function is a product of two things, then the derivative will be the derivative of the first term, which would be g prime of x, times the second term, h of x, plus the first term, g of x, times the derivative of the second term, h of x. So that's what rule we have to use if the function is a product of two things. In note card 18, we're going to learn the quotient rule. And here's what the quotient rule says. If f of x equals a quotient, g of x over h of x, then the derivative is going to equal something that looks really nasty. Okay, it's going to be g prime of x times h of x, but now it's going to be a minus g of x times h prime of x all over h of x quantity squared. All right, that's a mouthful. So you might wonder, where did they get this formula from? So I'm going to try to develop this formula for you. Okay. So let's go back to the original assertion here that f of x is a quotient. Okay. So let's imagine that f of x equals g of x over h of x. And for simplicity, let's just drop the x part. So let's just say f equals g over h. Okay. Well, if I this is a proportion, I can turn this into a proportion and I can cross multiply. So if I cross multiply there, okay, 1 times g would be g. If I cross multiply here, this would be f times h. Now my goal here is to get f prime. Okay, my goal is to get f prime. Well, from here I can use, if I want to find g prime, I can use the product rule. Okay. So the product rule says that we would take the derivative of the first times the second plus the first times the derivative of the second. All right, now if we let's try to get f prime by itself here. Yeah, let's try to get f prime by itself. If I wanted to get f prime by itself, then I would subtract f times h prime from both sides. F times h prime from both sides. So when we do that, those things cancel out. Now I have an equation that says g prime minus f times h prime equals f prime times h. If I wanted to get f prime by itself, I could divide everything by h. So when I do that, now I have that f prime, I'm just kind of putting that first, I'm putting this side first, equals g prime minus f times h prime all over h. Okay. But what is f? we go back here and we ask ourselves, well, what's f? F is g over h. So if I resubstitute that, I get g over h times h prime all over h. If I further break this apart, okay, I can take each term in the numerator and divide it by the denominator. So I have g prime over h minus g over h times h prime all over h. Well, what can I do now to make this look a little bit nicer? If I multiply this term by a fancy form of 1, like h over h, this h cancels that h. Okay. But the problem now is that in this term I have h times h. I have h squared. So to compensate, to get a common denominator there, I have to multiply by an h and an h there. So when I do that, here's what I get now. I get that f prime equals g prime times h over h squared minus g times h prime over h squared. So that's a common denominator. So g prime h minus g h prime all over h squared, and this is the quotient rule. That right there is the quotient rule. Okay. This right here says the same thing as this did. I just dropped the x's here. Okay. So I know that's really kind of like, what the heck? How am I going to remember that? Do I have to do that every time? No, you don't. So there's an easy way to learn the quotient rule. Okay. So the easy way to remember the quotient rule is the following. All right. Here's the saying. Okay, the quotient rule. So if f of x equals g of x over h of x, then to figure out f prime of x, you're going to remember this saying. Low d high, so low d high, minus high d low all over low squared. So low d high minus high d low all over low squared. Okay. So what's the meaning of these lows and the highs? Well, the high is the numerator. Okay. Why? Because it's on high. The denominator, since it's at the bottom, it's low. So if I apply it here, if I can remember that saying, it says low, take what's on the bottom, h of x, times the derivative, the little d stands for derivative, the derivative of what's on high, so that's the g prime, that would be g prime, minus what's on high, g of x, times the derivative of what's on the bottom, so that would be h prime of x, all over what's on the bottom, h of x squared. And that right there is the quotient rule. So if you can remember this, you're going to be okay. Okay, remember that saying. Low d high minus high d low all over low squared. So now let's do some problems where we apply this rule. So number 1 on the note card, it says if v of t equals t squared over 3t squared minus 2t plus 1, find v prime of t. So I need to find the derivative. So as I'm looking at the original function, I see a quotient, okay? And you're not allowed to break this up into pieces. Okay? If there were multiple terms in the numerator, you could divide each one by the entire denominator, but that's not going to help. Okay? So I'm going to use the quotient rule here because this is a quotient. Quotient's like a fraction or a division problem. Okay? So we're going to use our saying. The saying is low. Here's what's low. 3t squared minus 2t plus 1 times the derivative of the high. So the derivative of t squared would be 2t minus high, what's on top, t squared, d low, derivative of the low, so the derivative of this entire thing, so the derivative of 3t squared would be 6t, the derivative of negative 2t is simply negative 2, and the derivative of a constant would be 0, so I don't have to put in the plus 0. So that's low, derivative of the high, minus high, derivative of the low, all over low squared. Okay, so this right here is, again, that's the first line answer. Now, if this is a free response question, stop here. But if this is a multiple choice question, you might have to take it further. So how could we take it further? Well, there's a couple things we could do. Okay. You could distribute. That's one way you could do it. Or you could factor out a t to start with. I'm just going to choose to distribute. Okay, so I'm going to distribute those. 3t squared times 2t would be 6t to the third. Negative 2t times 2t is negative 4t squared. 1 times 2t is 2t. Now be careful on the next part because there's a minus sign. So you're actually going to be distributing a negative t squared to each of these. Okay, so you're going to be distributing the negative t squared to both of those. So negative t squared times 6t would be negative 6t to the third. Okay. And negative t squared times negative 2 would be positive 2t squared. And that's still over the 3t squared minus 2t plus 1 all squared. I'm going to leave that like that for now, because some nice things might happen. So, and then just try to simplify, combine like terms. So I have a positive 6t cubed, it'll knock out the negative 6t cubed. So what else do I have? I have a negative 4t squared and a positive 2t squared. If I combine those, that's negative 2t squared. So I took care of those two, and then I have a plus 2t. And that's all over 3t squared minus 2t plus 1 squared. Okay. For these two terms, I could factor out a 2t, or I can even factor out a negative 2t. Okay. So negative 2t, if I factor that out, I would have t minus 1. All over 3t squared minus 2t plus 1 quantity squared. If I think about the bottom, maybe that quadratic can be factored. Okay, so how do I get 3t squared? I have 3t times t. All right. If I put a minus 1 there and a plus 1 here, actually I can't do that. Okay, because this last term's got to be plus 1. These both have to be minuses, or they both have to be pluses. Based on the middle term, they would both have to be minuses. but then that doesn't make this term work out. So I really can't factor any more than that. So this would be the fully factored answer. This quadratic down here can't be factored. Okay. So this is just the factored version of the answer. Okay. Now the reason you might want to do that, sometimes something might cancel. But in terms of credit for a free response question, as soon as you get it to this stage, just leave it. There's no use in simplifying it. The only reason you would have to simplify it is if this answer didn't show up on a multiple choice, you might have to keep taking steps. So let's do the next problem. Number 2 says, what is the instantaneous rate of change at x equals 2 when the function is f of x equals x squared minus 2 over x minus 1. So let's think about what they really want me to find here. Instantaneous rate of change is another name for derivative evaluated at that x value. So I'm trying to find f prime of 2. That's what the question's asking for. Here's my function. Notice that the function is a quotient. It's a division problem. So the first thing I have to do is I have to find f prime of x. So we say low, what's on the bottom, d high, derivative of the high, derivative of x squared is 2x, the derivative of a constant is 0, so I'm not going to include that, minus high times the derivative of the low. Well, the derivative of 1x is just 1. The derivative of the constant 0, so I don't need to worry about that, all over the low squared. So here's my first line answer. Now there's really, if you think about it, there's really no advantage to simplifying this, because what I'm trying to do is I'm just trying to figure out what that value is. So there's really no use in simplifying here. All I'm going to do is everywhere I see an x, I'm going to plug in a 2. So 2 minus 1 times 2 times 2, that's 2x, minus 2 squared minus 2 times 1, all over 2 minus 1 squared. Now, if this was a free response question, you could actually leave your answer like this, and they would accept it. But if it's a multiple choice question, they'll simplify it. So let's just practice simplifying it. 2 minus 1 is 1. 2 times 2 is 4. Minus 2 squared is 4. Minus 2 is 2. There's a 1. 2 minus 1 is 1, and if I square 1, I still get 1. So 1 times 4 is 4. 2 times 1 is 2. So it's going to be 2 over 1, which equals 2. If you wanted to simplify this, you could, but it doesn't really do you any good based on what they're asking for. Okay? You just have to be careful on your arithmetic. Students do not miss the calculus. This is the calculus. What they miss is this. They miss the arithmetic, because they make just mistakes. They make arithmetic mistakes. Number 3. It says find ds over dt, which again means the derivative, for the function s of t equals 6t squared over 5 plus 2 over the cube root of t squared. Maybe I have to use the quotient rule, maybe I don't. So let's try to rewrite s of t a different way. Okay, so let's write it as 6/5 t squared plus 2 over, I can rewrite that radical as t to the 2/3 power. Okay, so if I just make it a little bit nicer, I can move this thing up here by turning it into a negative exponent. Plus 2 t to the negative 2/3 power. So when here's your function, you just have two terms. And neither one of those two terms is a fraction. You can use basic rules. So when it asks me to find ds dt, that just means the derivative. I'm just going to use my power rules and some of my basic rules. So 6/5 times 2 is 12/5. We reduce the power of t by 1, so it goes from the second to the first power. Okay. Now I'm going to do 2 times negative 2/3, that's negative 4/3. We're going to reduce this power by 1, so negative 2/3 minus 1 is negative 5/3. And there we go. That's a first line answer. Didn't have to use the quotient rule at all. You could have, but it's harder. Okay, it's harder. If I wanted to write that a little bit nicer, 12/5 t minus 4/3 times the cube root of t to the 5th power. That's another way you could write it. Or you could mess with getting a common denominator, but that looks nasty to do. Let's try number 4. So number 4 gives me a whole bunch of information here. So what does it tell me here? It tells me that f of 5 equals 1, tells me f prime of 5 equals 6, tells me g of 5 equals negative 3, it tells me g prime of 5 equals 2. And here's what it's asking me to do. It says find the derivative of g over f evaluated at 5. So I know it's kind of complicated notation, so let's let h of x equal g of x over f of x. Okay. So now if I do that, what I'm really trying to find is h prime at 5. That's what I'm trying to do. I just defined a new function. I said h was the quotient. Okay, before I can find h prime of 5, I need to find what h prime of x is. So if I'm going to find h prime of x, we're going to do our saying low. Right now low is f times d high, derivative of high, so g prime of x, minus high, g of x is on high, d low, the derivative of the low, derivative of f, all over low squared. And we're trying to find a specific value. We're trying to find h prime at 5, so everywhere I see an x, I'm going to put in a 5. Now what I can do is I can plug in those values that they gave me in the problem. F of 5, that equals 1. G prime of 5 equals 2. Minus G of 5 equals negative 3. Don't forget that minus sign. Okay. F prime of 5 is 6. Okay. Now it says f of 5, just be careful, f of 5 again was 1. And it was the same number we put in that very first spot, squared. Okay. Now if this was a free response question, you could stop here. They would accept that answer because it's correct. If you're going to simplify, you could do so correctly. 1 times 2 is 2, minus negative 3 times 6 is negative 18. 1 squared is 1. 2 minus a negative 18 is like saying 2 plus 18. And 2 plus 18 is 20, and 20 over 1 is 20. Number 5 says find the slope of the tangent line to y equals 3 sine of x all over 4 plus cosine of x at an x value of negative pi halves. So let's think about what this is really asking. When they say slope of the tangent, I'm thinking derivative. So y prime. Well, a tangent line exists at a specific x value. There's the x value. See, in this problem, they just want the slope. They don't want the equation of the tangent line. They just want the slope of the tangent line. So what I'm really trying to do is I'm trying to find y prime evaluated at negative pi over 2 radians, which again means negative 90 degrees on the unit circle. Before I can find y prime of negative pi halves, I have to find y prime for all of x. Okay, so we got to go to our y function, and we have to take the derivative. Well, y is a quotient, I have to use the quotient rule. Okay. Or I could use the quotient rule. So low, 4 plus cosine of x is on the bottom, times the derivative of the high, the derivative of 3 sine of x, well, the 3 stays there, times the derivative of sine is simply cosine, minus, okay, high, what's on high? 3 sine of x, times the derivative of the low. The derivative of 4 is, if that's a constant, the derivative of it is 0, but the derivative of cosine is negative sine. All over low squared. Now, what are we really trying to do? We're trying to find y prime at that point. Could you simplify this? Yes. Does it do any good to actually do that? Maybe, maybe not. It's up to you. I'm not going to. I'm just going to be really careful. Okay. So everywhere I see an x, I'm going to plug in a negative pi over 2. And if we're lucky with some of this trig stuff, maybe some of it will go to 0. Maybe like that. Sorry about that. Here it should say 4 plus cosine x. So if I want to think about it, negative 90 degrees on my unit circle, that's down here. So the coordinates here are 0, negative 1. What does that mean? The cosine down there is 0. So if I ever see a cosine of negative pi over halves, that thing goes to 0. Okay. Here I see another cosine of that. This thing goes to 0. 3 times 0 is still 0. And 4 plus 0 times 0, this whole thing goes away. Okay. Because this second parenthesis turned out to be a 0. Okay. Here, this cosine again, that's just going to be 0. So that's going to go away. Now what about the sine? The sine at that angle measurement is negative 1. Okay. So everywhere I see that sine of that radian measure, I'm going to plug in a negative 1. Okay. So what do we have here? Y prime at negative pi halves equals, so that's gone away. We still have that minus out front. Then we have a negative 1. This thing was negative 1, but there's another negative right there. So negative negative 1, which would be positive 1. All over, okay, 4 squared, 16. So what's negative times negative 1? positive 1 times another 1, positive 1 over 16. So there's my answer, 1/16. Let's use our calculator. Let's make sure we're right. So I'm going to put in the original function. Original function was 3 sine of x over 4 plus cosine of x. Okay. I'm going to do zoom, and since these are trig functions, I'm going to go to option 7, zoom trig. I care about the slope at negative pi over 2. So if I go second calculate, or second trace, go down to option 6, calculate the derivative at a point, and I want to calculate that derivative at negative pi over 2, and hit enter. Okay. To me, it looks like right here, the calculator is telling me that the derivative is 0.187. Okay. It's telling me that it's 0.187. I think the answer is 1 over 16. Okay, so I probably made a mistake somewhere, so I gotta find it. That's okay, people make mistakes. Okay, so let's just make sure. Let's kind of go back. You might have seen my mistake when I was making it. So low, okay, that's low. D high, okay, that is the derivative of the top, minus high, D low, okay, all over low squared, okay. That's 0, so that becomes a 4. That's 0, 3 times 0 is 0, 4 times 0 is still 0, okay. That's negative 1. Oh, I found my mistake. All right, here. I should have wrote, I forgot this 3 right here. Okay, this should be negative 3 times negative 1. It's positive 1, or it's positive 3, excuse me. I should have put a 3 right there instead. So the right answer should be 3 over 16. Okay, if I do 3 over 16, gives me the 0.1875, which was the same number we saw on the graph. Okay, so that's part of math too. Finding your mistakes. You know, I just found my mistake. It's okay. No worries. You can make fun of me if you want. All right. So let's do number 1 on the back side. It says find f prime of x. Find f prime of x if the original function f of x equals 2x minus 7 raised to the negative first power times 3x squared minus 2x. So what does this actually mean? When you see something raised to the negative first power, you can put that into the denominator, and it would just be to the positive first power. Now this thing just has an understood power of 1, so it stays in the numerator. Okay, and if something has something to the first power, you don't really need the parentheses. So it becomes 3x squared minus 2x all over 2x minus 7. So this is another way to write the function itself. And that's not what we're trying to get to. We want to find f prime. Okay, so how am I going to do that? I have to use the quotient rule. Low, 2x minus 7, times the derivative of the high. 3 times 2 is 6, so that would be 6x. The derivative of 2x is just 2. Okay. So low, d high, minus high, d low. What's the derivative of 2x minus 7? The derivative of 2x is just 2. The derivative of the constant is 0. I can leave that like that, all over low squared. this was a free response question, you could stop there. You don't have to simplify more than that. But if it's a multiple choice question, we have to get good at simplifying. So here's a FOIL. 2x times 6x is 12x squared. All right, 2x times negative 2 is negative 4x. Negative 7 times 6x is negative 42x. And negative 7 times negative 2 is positive 14. Now what about this next one? There's a minus and there's a 2 at the end. If you feel more comfortable and you want to move that 2 to the front, you're allowed to do that. The reason why, when you multiply two things, it doesn't matter what order you multiply them. Now you can distribute the negative 2 to both of those. So negative 2 times 3x squared is negative 6x squared. Okay, negative 2 times negative 2x is positive 4x. Okay, and that's still all over 2x minus 7 squared. Okay, so let's see if we can cancel anything. I have a positive 4x and a negative 4x. They cancel. Okay, if I combine these two terms, we got a 12x squared and a negative 6x squared. So when I combine those, it would be positive 6x squared. Okay, so I took care of that, I took care of that. And I have a minus 42x plus a 14. All over 2x minus 7 squared. Okay, can I factor any more? Maybe. Let's see. Out of these three terms, I can take a 2 out. And I don't think this will factor. Actually, I know that will not factor. That will not factor. All right, so that's as far as I can go with it. All right. So if you need to simplify it, one of those two answers will be there. If this was a multiple choice question. But if it's a free response question, again, just leave it like this. All right. Let's do number 2 on the back. It says find ds dt if s of t equals 2 over cube root of t squared minus 6t squared sine of t. So first thing I would probably try to do is I would rewrite it. I would rewrite this as 2 over t to the 2/3 power minus 6t squared sine of t. And I would probably move that up. So 2t to the negative 2/3 minus 6t squared sine of t. Okay. So my goal was to find ds dt. Another way we could have written that is s prime of t. So I want to find the derivative. Okay. So to find the derivative, I need to find the derivative of this minus the derivative of this. So I might just want to make some notes to myself, especially if things start to get complicated. I want to find the derivative of 2t to the negative 2/3. That's just another way to write derivative. Minus the derivative of 6t squared sine of t. So maybe just take care of one part at a time. Okay. So I'm just going to do a little bit of side work. I want to find the derivative of 2t to the negative 2/3 power. Let's just kind of do that on the side here. Okay. Well, just power rule. 2 times negative 2/3 is negative 4/3. We're going to make the power go down by 1. So we're going to subtract 3/3 and we're going to get that. And we could also write that as negative 4 over 3t to the positive 5/3 or negative 4 over 3 times the cube root of t to the 5th. Okay, so that's the first piece. That's the derivative of the first term. Okay, so that's the derivative of all that. And maybe off here to the side, we can find the derivative of the next term. 6t squared sine of t. Well, if you notice, that piece or that term actually has, this is a product. So I actually have to use the product rule on it. Okay, that's a product right there. All right, so how do I do the product rule? Okay. We take the derivative of the first. The derivative of 6t squared would be 12t times the second. And then with the product rule, it's always a plus. Plus the first times the derivative of the second. Derivative of sine is cosine. Okay. So this whole thing is the derivative of that second piece. So putting it all together, s prime of t would equal negative 4 over 3 times the cube root of t to the fifth minus, but you have to subtract this whole thing, so we're going to keep it in parentheses, 12t sine of t plus 6t squared cosine of t. So that's a perfectly acceptable answer for the derivative. Okay, if you wanted to do something a little bit more, not that you have to, okay, out of these terms, they both have a t in common and they both have at least 6. So I could have factored out a 6t, and then I could put 2 sine of t inside, okay, and then plus again, because I've already taken care of that the negative stayed out, okay, plus t cosine of t. Okay, so you could have also written it like this, you could have gotten a common denominator, you could have done a lot of other things with this. All right, a lot of steps in this problem, but if you just take your time, you're fine. So let's try number 3. It says find the x values, just the x values, if any, don't you love it when they say that, where the tangent lines, again, when you think tangent line, think derivative, tangent line to the function y equals 4x cubed over x plus 1 are horizontal. So that's our goal. So what does it mean to be a horizontal tangent line? That means that the derivative has to be equal to 0. The derivative, okay? Because that means the slope would be 0. Horizontal tangent line has a slope of 0. So before I can figure that out, I need to figure out what y prime of x is. Well, what is y? Y is a quotient, so I got to use quotient rule. Low, d high, derivative of 4x cubed is 12x squared, minus high, derivative of the low. The derivative of the low is simply just going to be 1 all over low squared. All right? And I want to figure out when is that going to be 0? At what values of x will that equal 0? So if I distribute, I'm going to get 12x cubed, x times 12x squared is 12x cubed, 1 times 12x squared is 12x squared, okay, When you multiply something by 1, it's going to be the same thing. So minus 4x cubed all over x plus 1 squared. Continuing to simplify, I have a 12x cubed minus 4x cubed. That would be 8x cubed plus 12x squared over x plus 1 squared. And if I factor a little bit, okay, what does 8 and 12 have in common? Well, 4 is in common, so 4 is a factor. They both have at least x squareds in them. So if I factor out a 4x squared, what's left? I would have a 2x plus 3. So how is this factoring going to help me figure this out? I need to figure out, when is this equal to 0? Well, if this thing equals 0, the only way that's true is if the numerator equals 0. Well, when is the numerator going to equal 0? When either this thing equals 0 or when that thing equals 0. So let's set each of those equal to 0, each of those parts. Let's solve them out. Okay, so here, divide by 4. Okay, so x squared equals 0. What number squared gives you 0? There's only one answer there. It's 0. Okay, so that's one answer. Here, subtract 3 from both sides. 2x equals negative 3. Divide through by 2, and x equals negative 3/2. Okay, so this function has two horizontal tangents. One happens at an x value of 0. The other happens at negative 3/2, which means negative 1.5. So I can kind of check myself here. Let's put the original function in. The original function was 4x cubed over x plus 1. I'm just going to zoom standard. I should see two okay, see part of it. So I might have to zoom out a little bit to see the rest of it. I'm not seeing everything I want to see. All right, so let's just use our calculator here to help us. If I go second calculate, if I want to find the derivative, what about 0? Okay, it says here the derivative at 0 is a number that 4 times 10 to the negative 6. That's like 0.00000004. So the calculator is estimating that to be around 0. And what about at negative 1.5? Same thing, 6.4 times 10 to the negative 5th. So basically, like if I zoom in, let me zoom in at an x value of 0, or roughly there. Hopefully you can see that you could draw a horizontal tangent right here. Okay. There's the one at 0. Okay. Let me do a little bit different zoom on here. Let me go up to 30. Okay, there's the other one. Really hard to see. There's a whole bunch of asymptotes going on in this graph. Okay. But hopefully you see up here, you see a little piece of it. Let me go up even higher than that so you can see more of it. So there's a horizontal tangent right there. at an x value of 0. And if I went up here to an x value of -1.5, that's where an x value of -1.5 is, and take it up, you could draw in a horizontal line right here as well. So for instance, trace -1.5. Right there, there would be a horizontal tangent line. And right here at 0, there's a horizontal tangent. Two more problems, guys. All right. So number 4, it says find d squared y over dx squared if y equals 7x times the cosine of x. So you got to remind yourself, what does this mean? Second derivative. And we can also write it as y double prime. So to find the first derivative, notice y is a product. So we got to use the product rule. Derivative of the first, 7, times the second, cosine of x, always plus the first, 7x, times the derivative of the second. The derivative of cosine is negative sine. So here we have y prime equals 7 cosine of x. All right, plus 7 times -1, that's -7. So I'm just going to write this as -7x sine of x. Okay. Now, how am I going to find y double prime? Well, that means I have to take the derivative of the derivative. So finding this derivative fairly straightforward. The coefficient stays 7 times the derivative of cosine, which is just negative sine. But what about for the next thing? Okay. This next thing is another product. So now you have to find the derivative of that product. So there's the two terms now. Okay. So derivative of the first would be 7 times the second, sine of x, always plus with product rule, plus the first times the derivative of the second. Derivative of sine is simply cosine. Right. So putting all this together, 7 times negative sine would be -7 sine of x. Okay. Now I'm going to kind of do two things at once here. I'm going to distribute that negative to both of those terms. So there'll be another -7 sine of x. Okay, and then the negative would distribute to the next term as well, so -7x cosine of x. Now both of these are like terms. Okay? They're both negative sine of x's. All right, so you can combine those, just like it's like -7x and another -7x. So that's -14, but at the end you have sine of x. Okay? Then you have a -7x cosine of x. So that's an acceptable answer. Or you could do some factoring. You could take out a 7, you could take out a -7. Let's say you took a -7 out. Took a -7, then you would have 2 sine of x. Okay, and then you'd have a plus x cosine x. Just some factoring rules. So we've already taken the -7 out, so that would have to be positive. All right, one more question. I know this is a long one, guys. So number 5, it says find the equation or equations of the tangent lines to y equal x minus 1 over x plus 1. So this is the function that are parallel to the line x minus 2y equals 2. So there's a whole bunch of stuff to review on this question. All right, what do you know about two lines that are parallel? If two lines are parallel, that means they have equal slopes. Okay. Parallel lines never cross, so they have to have equal slopes, otherwise they'll cross. All right, so the first thing I need to do is I need to figure out what the slope of that line is. Well, how do I figure out slope? Let's put it into slope-intercept form. Okay, so let's go ahead and subtract x from both sides. So now I have negative 2y equals 2 minus x, but I'm actually going to write it as negative x plus 2. And that's like negative 1x. Now I can divide everything by negative 2 to get y by itself. When I do that, I get y equals negative 1 over negative 2 turns into positive 1/2. And 2 divided by negative 2 is negative 1. So what piece of information is important there? This thing right here. That's the slope of that line. Okay, so this line has a slope of 1/2. Has a slope of 1/2. So I want my tangent line or tangent lines to be parallel to this line. So what does that mean? That means that my tangent line or lines will have a slope of 1/2 as well. Well, what's a tangent line? What's the slope of a tangent line? Slope of a tangent line means derivative. So I want to figure out where is the derivative equal to 1/2? Or in other words, where is y prime of what will give me 1/2? I'm trying to figure out where those x values are. So the first thing I have to do after this, now I've got to figure out what y prime is. How am I going to figure out what y prime is? Well, y is a quotient, so I need to use the quotient rule. Low d high, what's the derivative of x minus 1? It's just 1, coming because the derivative of 1x is just 1. The derivative of that part is 0. Minus high, x minus 1, times the derivative of the bottom. The derivative of the bottom, or the derivative of low, would be 1 again there, all over low squared. So if I simplify this a little bit, x plus 1 times 1 is simply x plus 1. All right, that 1 doesn't make a difference here. If you distribute out that negative, you would get a negative x and another positive 1 over x plus 1 squared. Okay. So here the x and the negative x cancel each other out. So the derivative function is 2 over x plus 1 squared. So I need to figure out where 2 over x plus 1 squared, that's the derivative, where does that derivative equal 1/2? Okay, so let's go ahead and solve this. How am I going to solve this? I'm just going to cross multiply. 2 times 2 is 4. 1 times all of this is simply going to be x plus 1 quantity squared. How am I going to undo a square? I'm going to take a square root. Just realize you got to put a plus or minus in front of there. So plus or minus square root of 4 is 2 equals x plus 1. So how am I going to figure out what x is? I'm going to subtract 1 from both sides. So what does that tell me about x? What's negative 1 plus 2? Negative 1 plus 2 is 1. What's negative 1 minus 2? It's negative 3. These are the two x values. Okay, those are the two x values. But what I really need to do is I need to find the equations of the tangent lines. So there's 2 points on the graph that give me a slope of 1/2. Okay? One point has an x value of 1. Another point has an x value of negative 3. But in both cases, the slope is 1/2. So I'm still missing the y value. How am I going to find the y values here? I'm going to plug these x values individually into my function. So if I plug 1 in, 1 minus 1 is 0, 1 plus 1 is 2, 0 over 2 is just 0. Okay. When I plug negative 3 in, negative 3 minus 1 over negative 3 plus 1, negative 3 minus 1 is negative 4, negative 3 plus 1 is negative 2. Negative 4 divided by negative 2 is positive 2. Okay. So my two tangent lines, I have two unique tangent lines here. The equation for the first one would be y minus 0 equals 1/2 x minus 1. That's one answer. And the other answer is y minus 2 equals 1/2 x minus negative 3. And those two negatives next to each other come here. All right. The way to check it in the calculator here, I'm going to put the original function in to my calculator. X minus 1 over x plus 1. I'm just going to do a zoom standard. Let's just check the points real quick in the slopes. So go second calculate, go down to number 6, type in that negative 3x value. When I do that, I'm going to get a couple pieces of information. It tells me the point is negative 3, 2. That verifies that. And then if I look there and dy dx, it says the slope is 0.5, which is the same thing as 1/2. So as long as I put these numbers correctly into here, I'm right. Now let's check the other one. Go back to second calculate, number 6. Now put in an x value of 1. Okay, so my point is 1, 0, and my derivative is 1/2. My point is 1, 0 on the curve, and the derivative there is 1/2, which is this. Point's 1, 0, the derivative's 1/2. So it looks correct. This is an incredibly difficult problem. Doesn't look like it when you first read it. I mean, it's one sentence, but there's so much work you have to do to get there. Very, very difficult question. So your assignment tonight is to do packet 18. So on the first couple problems, it just gives you practice taking a derivative. And the next problem, you have to take a derivative and find the equation of the tangent line and move stuff around once you find your equation and make it match one of these forms. Kind of a review about differentiability and continuity. More practice taking derivatives. This is really hard. I want you to think really hard about this question. Maybe draw graphs to help you out. Okay, and that's it for the homework. Sorry for the length of this video, guys. There's just a lot of notes on this note card.